So hi everyone, myself Mullah Sohail and I am from Minerva. So today I'm going to continue with the class which we have left before. So we discussed in the last class about relations. So we started chapter 1, relation and function. So we are continuing that chapter and today we will be discussing the new topic, that is function. Now before starting with the chapter, we should know that what are the different things we are going to discuss. First we are going to start with the definition of function. And then we'll move on to what is domain, range, codomain. About domain, range and codomain, we have already done this one in relations. So the definition of domain, range and codomain, they are not different for function. They are the same thing, but still we'll just go through that. And we have real valued function, real functions. So types of function, identity function, which you have already came across in class 11. Then we have composite function and invertible function, and that will be end. Now in your syllabus there is binary function also, binary operations. Now since there is a syllabus reduction in this year, so I will not be covering that portion of that chapter. So starting with the definition of function, so what we have is, what is a function? So function is nothing but a special kind of relation. So it is a special kind of relation. Now how special is it? How special is it? Now listen very carefully. If I take two sets A and B, now if I take two sets A and B, now obviously if I am taking two sets, so there will be elements of A. Now say let 1, 2, 3 be the elements of A and 4, 5, 6 be the elements of B. Now when I say that every element of A must have a unique image. Now what is image? Suppose I say 1 is mapped with 4. So I can say that this 4 is an image of 1. 2 is mapped with 5. So 5 is an image of 2. So like this way, for a relation to be a function, the important criteria it must satisfy is that every element in A must have a unique image in set B. That is what a function is. Now how do we denote a function? We denote a function like this way: F colon A to B. F colon A to B. This is how we denote a function, where A gives you the first set. This is the first set through which the elements, now look at here, 1, the arrow is going towards 4. So here I will write F. So the function is mapping the element 1 in A to the element 4 in B. It's called mapping. Okay, mapping of elements. So this is how. Now what is a B? B is this portion. The second set gives you B. So that's how we denote a function. F of A to B. Right? Now listen very carefully. Now if I have to write elements of the function, what are the elements of the function? In here 1, 4 is an element. 1, 4 is an element. Then 2, 5 is an element. Here we can write element of the function. Now 2, 5 is an element of the function. So like this way, and 3, 6 is also element of the function. So like this way we determine a special kind of relation, now which is also known as function. Now if I say, I will give you an example. Suppose like this, a different thing. Suppose I have two sets C and D. I have 1, 3, 7 in here, and 3, 31, 27, 36 in here. Now if I make the arrow here to here, then here to here, now here to here. Now my question is this a function? Is this relation a function? Yes, it's a function. Why? Because the criteria of a function, for a relation to be a function, is that every element must have a unique image. 1 has a unique image, that is 31. 3 has a unique image, that is 31. And 7 has a unique image, that is 36. So this is a function. Achha, another example which is not a function. Let me do that thing. Let me show you another example which is not a function. Suppose I say I'm doing from A, not A, we have already used A. Let us do from X to Y. Now I am writing here 1, 2, 3, and then I have 4, 5, 6. Now if the mapping happens like this, 1 to 4, 1 to 5, 3 to 6. Now look at here, this one this relation is not a function. Why? Because every element in X does not have a unique image. The element 1 has 2 images. The element 2 has no image at all. So this relation is not a function. So this is how we denote whether a relation is a function or not. This is how we denote a function from A to B. Now, what is domain? We already know what is domain. So domain is a set of all the elements in A which are related to the elements in B. So in here you see 1, 2, 3, that's our domain. So this A, when I'm writing the function A to B, basically this first set gives you the domain. The first set, whenever I'm writing a function in the form of like this, always remember this first set A gives you the domain. Now the next one, what is the range? Range is, look at here carefully. Now you will say, sir, range is B, A to B. Listen very carefully. Here for this one it's correct, range is B. But for this one, is it correct? This one's still a function, right? So this B does not gives us the range. This B is actually what? This B is nothing but codomain. This one is codomain. So what gives us range? So for this question, the range is 4, 5, 6. That is B. Very good. But for here, this one is also a function. But here the range is not D. The range is 31, 36. Clear? So I hope we have got the idea of what is domain, range and codomain. Now we move on to the next topic. That is real valued function. So what is a real valued function? Now from the name of it, it suggests real. Now what is real? Real numbers. You think of real numbers. We know real numbers extends from, what should I say, minus infinity to infinity, right? So 1.1, 1, 2, 3, 2.3, all of them are real numbers. Even rational numbers are also real numbers. Irrational numbers are also real numbers. So you just think of all the numbers in a number line. Real valued function. So it means what? If the value of a function, if the values of a function are real numbers, then we call that function to be real valued function. Simple as that. If the values of the function are real numbers, are known as real valued function. Now listen very carefully. Among these domain, range and codomain, which one does give the value of the function? This domain is what? This domain is this one, 1, 2, 3. This is the domain. Now, before doing this thing, let me just tell you one thing. So if I have to write this function in a form, look at here. If I have to write f of 1, what is f of 1 is equal to? F of 1 means the function is mapping 1 to which element? 4. So the value of the function at 1 is equal to 4. The value of the function at 3 is equal to 6 for this one, okay? For this type of function, the value of 1. Now you see here, the value, when I'm talking about value, the values means what? The elements of the set B, the second set, right? So when I'm saying real valued function, so the values will be nothing but the range we are talking about. So the range has to be real numbers. Simple as that. So write down. So real valued function, the function whose range is real numbers are known as real valued function. Now the next one, what is real function? What is real function? Now real function is those function whose range as well as its domain is a real numbers, is a set of real numbers. Whose range as well as the domain is set of real numbers. I call them as real functions. Now, let's move on to the topic types of function. So what are the different types of functions? Now in class 11, we have learned so many functions, that is rational function. Then we have learned about polynomial function, modulus function, signum function. All those functions we have learned in class 11. But here we are going to learn a different types of functions. So what are those functions we are talking about? Wait a second, let me rub. Yeah. So the first name what pops out in there is that 1, 1 function. So what is 1, 1 function? The first topic is 1, 1 function. Now from the very name you see, The function basically means what? Mapping. Function basically means mapping. Mapping of one element to the other element. Now 1, 1 means what? It's a mapping of one element to the other element. So it means, let me draw that thing. Suppose I have a set A. Suppose I have a set A and a set B. And the elements of set A is 1, 2 and 3. The elements of set B is 4, 5, 6. So what kind of mapping of the elements in A to the elements in B makes it a 1, 1 function? Let's look at very carefully. 1, 1. So I pick one element of set A, then I mapped it with one element of set B. I pick one element of set A, the other element of set B. This is how we get 1, 1 function. So one element of set A is mapped with a unique element in set B. Clear? So this is how we get 1, 1 function. Now, when a function is not 1, 1, look at here. Suppose I have 1, 2, 3, 4, 5, 6. Now, 1 with 4, 2 with 5, 2 with 5, then 3 with 5. This is what we have. Now, this function you see, here I cannot see 1, 1. Why is that? 1 is mapped with 4, right? 2 is mapped with 5. 3 is mapped with 5. So this basically means what? Look, it is a function. Why? Because every single element has a unique image. But you see, 2 and 3 has one image. I told you what the definition of 1, 1 is what? Every distinct element in A must have a distinct image in B. But here, the criteria is not followed. Every distinct element in A does not have that. 2 and 3 does not have distinct image. They have the same image, that is 5. So here, this type of functions are known as 1, 1 function. So every distinct element in A must have a distinct image in B. Clear? Now the next topic is already in the board. Many-to-one function. Now what is many-to-one function? Look at here. This is my many-to-one function. 1, 2, 3. Look, 2, 3. More than 1 means many. So 2, 3 is mapped with one element. So many to 1. If I write here 4 also, it's mapped with 5. So many to 1. These type of functions are known as many-to-one functions. Okay? When 2 or more elements are mapped with a same element in B, then we can say those type of functions to be many-to-one function. Now let's move on to the third topic, that is onto function. Onto function. Now what is onto function? Now here we cannot say by the name of it. So onto function is nothing but, look at here carefully. Here there is no significance of the name, because obviously every answer you cannot find from the name. So this kind of like this is a different, it does not relate anything with its name. So onto function is what? Suppose I have two sets A and B. When can I say, let me write the elements also, 1, 2, 3, 4, 5, 6, 7, let me write here 4. So onto function is nothing but, it's a function in which every element of B needs to be an image of any element in A. So every element of B needs to be, it must be compulsory, then only it can be onto. So every element of B must be an image of an element in A. 1, 4, 2, this one, 3, 5, 4, 6. Now, somebody asks you, is this a onto function? No, it's not an onto function. Why? Because the element 7 is not an image in of any element in A. So this is not onto. So what will be onto? So onto will be C, D, 1, 2, 3, 4, 5, 6. So here to here, here to here, here and here. This one is my onto function. I have to write F in here because for functions we need to write that thing. So here we have an onto function. Why? Because every element in set B is an image of one particular element in set C. So this one is onto function. So this one I will write F C arrow D. So now if somebody asks you what is the value of the function F at 4? So the value of the function at 4 will be equal to what? Now 4 is mapped with 6. So F4 will be 6 and F3 will also be 6. Here, what is the value of F4? 6. F3, 5. They are different, right? Okay? Because there are different functions, so different values. Now, and we cannot have any function. We cannot put anything. We don't have anything in here, right? That's why this one is not onto. This is onto. Now, with this definition, with the definition of onto, we come across into. Now, what is into? Something just like one-to-one, many-to-one. All those functions which does not follow the criteria of one-to-one is many-to-one. So, all those functions which does not follow the criteria of onto function is into function, right? So, what is the criteria? So, there must be at least one element. There must be at least one element in B who is not an image of any element in A. So write down for into function is what? There must be at least one element in B which is not an image of any element in A. So that makes it into function. Okay. Now this whole 4 part is clear. Now the last one, what is bijective function? Now bi means what? 2. What is bijective function? So functions which are 1, 1 and onto both are known as bijective function. So bijective function. So functions which follows the criteria of 1, 1 and onto both the criteria have to be satisfied. Then only we can say that the function to be bijective function. So if I have to go with an example, so 1, 2, 3 and 4, 5, 6. 1 with 4, 2 with 5, 3 with 6. This is a bijective function. Because you see, every element in set A has a distinct image in set B. That is the condition for 1, 1 function. And the condition for onto function is what? Every element in set B is an image of a distinct element in set A. So, and one thing, from where this jective terms came? Listen carefully. This 1, 1 function is also known as injective function. This is also known as injective function. And onto function is also known as surjective function. So that's how jective came in here. Okay, combining those two, we get bijective function. So this type of function is clear. Now we have identity function. So what is identity function? We have done identity relations. So identity function. Now, a function f colon A to B. Sorry, A to A. It's not A to B, A to A. It's the same set. I'm mapping the function of the elements of the same set. So when a function f is mapped from the elements of A to the elements of the same set A is defined by, the function is defined by fx is equal to x. If it is defined by fx equal to x, then we can say that this type of function is known as identity function. So fx is equal to x means what? It means if I have f of 1 is equal to 1. If I have f of 2 is equal to 2. And if I have f of 3, and that is equal to 3. So you see, if I have to draw the arrow diagram, what we get from A to A, 1, 2, 3, 1, 2, 3. So 1 will be this one, 2 will be this one, 3 will be this one. So this is known as identity function. Now how do we denote identity function? We write identity function as IA. I stands for identity and A stands for identity in the set A. So that's what identity function is. Now we have composite function. Now the next topic is composite function. So what is composite function? So suppose there are two functions. One is f colon a to b. And another function is g colon b to c. Clear? So let us draw this arrow diagram of this a to b with an example. So suppose I have a in here and I have b in here. And the elements of a are 1, 2, 3. The elements of b are 4, 5, 6. Here b is the same element. I am discussing the same question, so the b will be the same thing. So here also b has 4, 5, 6. And c, let me write it to be different, 7, 8, 9. So composite function is nothing but, it's just like composite of these two functions, fx and gx. Achha, let me do the mapping also, because how can I finish the function without doing the mapping? Because that's the most important thing. This is what we have. This is f function and this is g function. So composite of two functions gives us another function. And that function is denoted as f of g. That is f of g. Now how will I do f of g? Now look, what is f of g? F of g, the starting is a and it ends at c. This is how we write composite of two functions. Now if I combine these two, what do we get? So a portion, what is a? Set a is what? 1, 2, 3. 1, 2, 3. And set b is what? Set c is what? It's 7, 8, 9. 7, 8, 9. So basically what I am doing, I am mapping 1 with 7, 2 with 8 and 3 with 9. So this is our f of g function. So this is a and this is c. So composite of f function and g function is denoted by f of g. That's how we denote. Now, if I ask you a question, what is f of 2 equal to? F of 2 is equal to what? It is equal to 5, because the function at 2 is mapped to the element 5. Another one, if I say, what is f of 5 is equal to? And what you will say? F of 5 is equal to 8. Very easy. F of 5 is equal to 8. Just I will see 5 is mapped with 8. So f of 5 is equal to 8. Now my question comes, what is f of g? F of g 2 is equal to? What is f of g 2 is equal to? Achha, there is a problem. Wait a second. F of g, not 2, f of g. Yeah. Achha, fine. F of gx is equal to. I will be denoting every single values in there. I'm just denoting the basic one. F of gx. What is that equal to? So f of gx is equal to what? I will write this one as f of gx. Like this. F of g is denoted by f of gx is denoted by f of gx. So you put inside gx inside f. So that's how we write. Okay. Now f of 2 is 5. G of 5 is 8. So if I have a question, what is f of g of 2? What is that equal to? So how will I write? So I will write this thing as f of g2. I will write f of g2, and g2 is how much? G2 is how much? Acha, we have done one problem in here. G2, look at here, f of G2 is what? 8. So I will write here 8 in here. Okay, clear? So that's what you got. Now, so that's how we get composite function. Now, let's move on to the last portion, that is invertible function. Now, what is invertible function? Now listen very carefully. Let there be a function f which is defined f a to b and y be an arbitrary value in b. So what I am doing is, in order to define invertible function, in order to understand invertible function, I will just assume one function f a to b, and I will take an arbitrary value y in b. So these two things will do. So what I will say that, now listen very carefully. So this function a to b, this function a to b must be, this function a to b must be 1 1 and onto. This function must be 1 1 and onto. Now listen very carefully. So what we have, it's an arbitrary value. So there must be, now if I say a, set a to b, this is a function, set a to b. If it is mapped from, I will take what? One value of, let there exist any one particular value x, such that it will be mapped with y in b. So what I will do is, there exists a unique value, a unique element x in a, such that gy is equal to x. So this is how we have the inverse function. So first x is mapped with y, then you see in the inverse function thing, y is mapped with x. So if this is what happens, then we can say that this function g is nothing but, it is inverse of f. So we can derive the conclusion. So g is the inverse of f. G is the inverse function of f, and it is denoted by f inverse. So if g is from b to a, so in place of g I can write f inverse b to a, or else we can write f inverse y is equal to x. So that's how we can say that the function f is an invertible function and the inverse of that function is g. So what is the necessary condition? The necessary condition for a function to have an inverse is the function needs to be 1 1 and onto. If it is not 1 1 and onto, the function cannot have inverse. That's the most important criteria. So that's how we finish today's lessons. So let us jump into some problems. Achha, before doing something, let me discuss one particular topic which I hope you guys have already done. Let me see. Algebra functions. Yes, algebra functions we have done in class 11, right? But let me just go through it a little bit, because while solving these function problems we need it. So what is algebra function? So if we have f plus g, that is addition, x is equal to fx plus gx, or for minus sign it is also the same thing. So I will write, this is how we do algebra functions. So algebraic operations is also applied in functions also. If I have fgx, that is what? Fx into gx. That is fx into gx. Now if I have f by gx, that is what? Fx by gx. Provided gx not equal to 0. So this is what algebra functions, which you have learned in class 11. The reason for me to discuss this thing is because you will be needing these while solving some questions. So let me just jump into some problems. So we have a question in here which we need to discuss. So here let A is equal to 3, 4, 6, 8 and B is equal to 5, 7, 9. Then draw the figure for the function. This is the function they have given from A to B, and hence state the type of the function, what are the domain and range of the function. So this is what is given in the question. So let us do it first. Let us draw the function first. So what we have? The function, what are the first elements? 3, 4, 6, 8. So we have 3, 4, 6, 8. This is my A. And we have B as 5, 7, 9. So how did they do the mapping? 3 with 5, 3 with 5. Then 4 with 7, 4 with 7. Then 6 with 7. Then we have 8 with 9. So this is how they have done the mapping. So this is my F. Okay. Now they have asked, state the type of the function. So what type of function is this one? So first thing you see, 3 has one element, 4 and 6 have the same element. So this is many to one function. First is, this one is many to one function. And then the next one was onto and into. But look at here, every single element in B is an image of an element, at least one element in set A, right? Every single element, they are image. So it means it is onto function. It is onto function. So this states the type of function. Now the next thing is what is the domain and range? And it's the simplest question. The domain is what? 3, 4, 6, 8. That is A. And the range is what? 5, 7, 9. That's it. So here we start our second question of the day. So here let A is equal to 1, 2, 3, B is equal to 3, 4, 5 and C is equal to 5, 6, 7, 8, 9. So such that F colon A to B and G colon B to C, they are the two functions where Fx is given by x plus 1 and Gy is given by y plus 2. So we have to find the composite of the two functions g of f. Now in teaching the composite function, we made a mistake in there. We tried to find g of f. Okay, we tried to find g of f of 2, but it was wrong. It was wrong. It would have been the composite of two functions, that is fx and gx. It will be g of f of x. This one will be, we made a mistake in there. I'm very, very sorry. We made a mistake. So it will be g of f of 2. So this can be written as g of f2. And I remember that thing. f2. 2 is mapped with 5. 2 was mapped with 5. So it will be g5. And then 5 was mapped with 8. So we get that g of f of 2 is equal to 8. So we made a mistake in there. So it won't be f of g. It will be g of f. Okay. So let us proceed with this question. So here they have given where f is a to b. And let us write the function elements. So fx is x plus 1. So the first function they are talking about. So fx is equal to x plus 1. Let us do this mapping first. So first thing, it is from A to B. Now A is what? 1, 2, 3. 1, 2, 3. And B is 3, 4, 5. So fx is equal to x plus 1. So if I ask you what is f of 1 is equal to? F of 1 is equal to, you will just in place of x put 1. 1 plus 1. That is what? That is 2. Right? So here I cannot map in here. Am I clear? But what is f of 2 is equal to? F of 2 is equal to what? F of 2 is equal to 2 plus 1. That is what? 2 plus 1 is 3. Now f of 3. What is f of 3 is equal to? That is 3 plus 1. That is equal to what? 4. So 3 plus 1 we have in here 4. Like this way we do the mapping. So here we have the question in here. So what I will do is, there was a problem in the previous question, so I just corrected that question into, here we have 2, 3, 4, 5. Because if we take 3, 4, 5, it is not forming the function actually. So there was a mistake in the book. So what I will do is, I will write first form the function, the elements. So what we have in here, A is 1, 2, 3. And here B is what? B is our 2, 3, 4, 5. So here the function fx is given by x plus 1. Fx is equal to x plus 1. So first of all, what is f of 1 is equal to? F of 1 is equal to 1 plus 1, that is 2. So 1 is mapped with 2. In the same way, 2 plus 1 is, f of 2 will be 2 plus 1, that is 3. Then 3 plus 1 will be 4. This is how we do the mapping. Now the next thing you see, there is a g function. So the g function becomes what? So gx, let us do this diagram. So we have in here, this is our b, and here we have c. So the g function is given by 2, 3, 4, 5 here, 2, 3, 4, 5, and g is your 4, 5, 6, 7, 8, 9. Okay, I have changed the question. I inserted 2 in here, so I need to insert 4 in there. So if I do the mapping in here, what it will be? So gx is equal to what? That is equal to y, gy is equal to y plus 2. Gy is equal to y plus 2. So g2 is equal to what? I am starting with 2. It won't be g1. It will be 4. So 2 is 4. G3 will be what? 3 plus 2, that is 5. G4 will be 6. G5 will be 7. So this is how we map the g function from b to c. So this is how we map the f function from a to b. So we have to find the composite of g of f. So let us do it. Let us do the composite of g of f. So g of f is equal to, what will be it? Look at here. First thing we'll find, I'm combining these two, right? So this will be, combined form will be written as, first I will write, it will be g of f colon a to c, right? So it will be a in here, and here it will be c. So what we have, a, 1, 2, 3, 1, 2, 3, and c what we have, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. Now if I have to do the mapping, g of f. So first thing we need to find the elements. So first one, I will find g of f1. What is g of f1 is equal to? I told you when I'm writing g of f1, so it becomes g of f1. Now f1, you know from here mapping, f1 is 2. So I will write here g of 2, and g of 2 is equal to 4. So it's 4. So 1 is mapped with 4. Right? Now the next one, g of f, the next element is what? 2. So 2 is equal to, I will write g of f2, and that is equal to what? G of f2. f2 is equal to 3. That will be g of 3, and g of 3 is equal to 5. So this one is 5. Now g of f3. Acha, 2 is mapped with 5. And g of f3 is equal to what? G of f3. And that is equal to, f3 is how much? From here, f3 is 4. So I will write there g4. So I got that one as, I got this one as g4 is how much? G4 is 6. So this one will be 6. So here I will map 3 with 6. So this is how we find composition of two functions f and g, that is g of f. We made a mistake while discussing composition of a function. Composition of f and g is g of f. It's not f of g. It will be g of f. Okay. So this question is done. So if I have to write the answer, so the composite function will be, So G of f, the answer will it be, for 1 it is 4. So 1 comma 4. Then it will be 2 comma 5. Then it will be 3 comma 6. That's my answer of G of f. Now let us solve the next question of the day. So what do we have in here? Let f be a function defined from R to R. You see here the domain is also R, codomain is also R, or else we can say the range is also R. So this function is what? A real function. So domain and codomain or the range is R. So it's a real function defined by fx is equal to mod x plus x, and g is also a real function defined by gx is equal to mod x minus x. For all x element of R, we have to find f of g and g of x. So let us do it. Now first thing, f of g, I told you what? Now here the variable is what? X. So f of, we have to write gx. So that will be equal to what? So f of g, it means we are doing composition of these two. So it will be f of gx. Okay? Understood? F of gx. Now if I have to tell you, the function will look like this. F of g, right? So here the functions will look like, suppose I have R, right? The mapping goes like this one. Now this R to R, when I'm doing f of g, this is f of g. This function is the g function. It's not the f function. There is the g function, and this function is the f function. So the combination of this composite of g and f gives us our f of g, not g of f. Please be very, very clear about that. So what is f of gx? So f of gx is equal to, look at here, gx function is what? Gx function is mod x minus x. So I will write f of mod x minus x. I will write gx in there. Now what do we have? Gx function. Fx function is what? Fx function, you look at here, it is mod x plus x, right? But we don't need to find fx. We need to find f of mod x minus x. So if fx is my mod x plus x, so I ask you, what is f of a is equal to? Mod a plus a. So suppose x is the king, so he will sit here and here. So now the king changed into a. So a will sit wherever x used to sit. Okay. So here you see, now first x was the king. So x used to sit in between mod. Then x used to sit in here. Now f is what? Mod x minus x. So mod x minus x is the king now. So he will sit where? Wherever there is x, he will sit. Now look at here, what I'm writing. Mod I will write first. So in place of x, I will write mod x minus x. Then plus, in place of x, I will write mod x minus x. So this is how we find f of gx. Now that's it. We don't have to solve any further. So that's my answer. Now what is g of fx? G of fx is what? G of fx is, again, you put fx inside g. So that is g of fx. Now what is fx equal to? Mod x plus x. G of mod x plus x. This is my fx, right? Now again you see, gx is mod x minus x. So g of mod x plus x will be what? So wherever you see x in there, you put mod x plus x. So it will be what? Mod of, you see x in here. So in place of x, I will put mod x plus x. Then minus, you see x in there. In place of x, what I will put? Mod x plus x. But here there is a problem. If you leave it this one, if you write this one to be the answer, it will be wrong. It has to be, bracket has to be in there. So it will be mod x plus x minus mod x minus x. That will be your answer. So you see, it's not equal, right? So we can say that f of g and g of f cannot be equal. So this is how we finish today's class. So thank you everyone for attending and listening to my class today. So thank you everyone.